We now discuss the solution of a problem from the section Differential Calculus, and the problem is on the applications of derivatives, and in this paper this is the second question appearing on applications of derivatives. This question has appeared in Joint Entrance Examination Main held on 24th June 2022 in the first session. The problem is, if the tangent at the point x1, y1 on the curve y is equal to x cube plus 3x square plus 5 passes through the origin, then the point x1, y1 does not lie on the curve. We are given four options. Option A, x square plus y square by 81 is equal to 2. Option B, y square by 9 minus x square is equal to 8. Option C, y is equal to 4x square plus 5. Option D, x by 3 minus y square is equal to 2. So we are given a curve. Y is equal to x cube plus 3x square plus 5. And x1, y1, the point lies on it. And the tangent at this point to this curve passes through the origin. Then this point x1, y1 does not lie one of the following curves given in A, B, C, D. That's the given problem. We now discuss the solution of the problem in detail. We have this given curve, y is equal to x cube plus 3x square plus 5. Call it as the equation 1. And given the point x1, y1 lies on this curve 1, therefore it satisfies that equation. Therefore substitute x1, y1 in the equation 1. We get y1 is equal to x1 cube plus 3x1 square plus 5. Call it as the equation 2. And the tangent at this point x1, y1 to the curve 1 passes through the origin. Therefore, we have to first find the tangent. For that, we need the slope of the tangent at x1, y1. The slope is given by the derivative of y, that is dy by dx at this point x1, y1. And when you differentiate this equation 1, then you will get dy by dx is equal to 3x square plus 6x, and at the point x1, y1 will be 3x1 square plus 6x1. Now the equation of the tangent at this point x1, y1 is equal to y minus y1 into the slope at x1, y1 multiplied by x minus x1. Substituting, then this equation is the equation of the tangent, and it is given that it passes through 0, 0. So put x is equal to 0, y is equal to 0 in the above equation. We will get minus y1 is equal to 3x1 square plus 6x1, that is the derivative at x1, y1 multiplied by 0 minus x1, that is minus x1. Cancel minus on both sides. You will get y1 is equal to 3x1 square plus 6x1 square. So y1 is equal to 3x1 cube plus 6x1 square. Now what is y1? y1 is given by 2. So go to the 2, take x1 cube plus 3x1 square plus 5, substitute here for y. We will get x1 cube plus 3x1 square plus 5 is equal to 3x1 cube plus 6x1 square, and simplifying we get 2x1 cube plus 3x1 square minus 5 is equal to 0. A very careful observation will reveal that x1 is equal to 1 satisfies this equation. If you put x1 is equal to 1, 2 plus 3, that is 5 minus 5, 0. So x1 is equal to 1 satisfies this equation. By inspection, x1 is equal to 1 is a solution of this equation 3. And if x1 is 1, what will be y1? That you can get it from equation 2. So from 2, y1 is equal to x1 cube, 1 cube plus 3 times 1, 4, 4 plus 5, 9. So y1 is equal to 9. So what is the point x1 comma y1? That is 1 comma 9. Now we proceed further, and what is that curve that is given in the options A, B, C, D, on which this point does not lie? That is what we have to see. We continue. We have the curve given by 1. We have x1, y1, 1 comma 9. And we have the options. And we have to see what x1 comma y1 does not lie on the curve given in option A, B, C, D. x1, y1 is 1 comma 9. And if you see option A, put x is equal to 1, y is equal to 9, you will get 1 square plus 9 square by 81, 81 by 81. So 1 square plus 1, that is 2. It is satisfied. So option A, notice that 1 comma 9 satisfies this equation. Therefore, x1 comma y1 lies on this curve. Similarly, go to option B, put y is equal to 1, x is equal to, y is equal to 9, x is equal to 1, then you will get y square, that is 81 by 9 is 9, 9 minus 1 is 8, so equation B is satisfied. Similarly, equation C is also satisfied by this point 1 comma 9. So similarly, we find that the point x1 comma y1, that is 1 comma 9, satisfies the equations that are given in option B and C. Therefore, x1, y1 lie on these curves. But we have to find that curve on which this point does not lie. So obviously, the three options have gone. So obviously, the fourth option, that is option D, is our answer. Let's see whether this point satisfies this or not. It should not satisfy. So option D, x by 3 minus y square is equal to 2, and x by 3 is 1 by 9, 1 by 3 minus y square. 81 is certainly not equal to 2. Therefore, it does not satisfy this equation. Therefore, this point x1, y1 does not lie on the curve given in option D. So our answer for this question is option D. And this is a very straightforward question from the section, applications of derivatives, and it is from the calculus. And I am sure that you understood the solution of this problem, and I wish you all the best. Thank you.